whether it's in AWS or Azure or OCI or on-prem or GCP, all of my different servers in one place and how they're performing. This might seem simple, but you'd be amazed how many people I know who have Azure Monitor up, CloudWatch up, the OCI user interface, and like Prometheus, all in one place. And they're jumping from one screen to the other. So pretty basic is just let's get all these things into one, and this is for your hosts. It's also around Kubernetes specifically, with this idea of, look, I want to be able to just say, look, show me all of my clusters, wherever those are sitting, whether it's AKS, EKS, GKE, on-prem, all these different ones. I want to see them in one place, and I want to be able to go and say, okay, show me, like if I go and I look at like a node or something, I want to be able to save the time by going, all right, show me the YAML for this node in one place, show me the pods that are running in this node and what their status is, show me how this node connects to other sources of data here. So that's the first ideas. And again, this is Datadog's way. You could build this yourself. There's other tools in the market, but a need is one, get everything together in one place. And the next one then is this shift to microservices. And the solution for this is distributed tracing. When I say distributed tracing, do people know what I mean? Not so. So it falls under the idea of application performance monitoring, but it's more important than that. Because there is like, what's the throughput and latency and like that kind of idea. It's more about if a request comes through, like if I go and I say, oh, like this is the issue with distributed systems. Our demo system is a web store. We have on the downstream a shipping service, a promotion service, a notification service, a product recommendation service, a payment service, a user database. There's a shocking number of different upstream and downstream components. And the trouble there is that if I go and I say, okay, I know I'm having an issue, let's say, with the web store. So I'm going to go and I'm going to look at my web store, and I'm going to look at my errors, and customers say that they've been having issues, let's say, with checkout. A lot of times what we're seeing is this. We're seeing, okay, someone's trying to check out, and they're getting a 500 code, and then that gets handed over to the development team to try and figure out why. I'm literally working with a customer on this right now, where all they know is the front end and the user support team are getting calls that the checkout's not working, but they can't figure out what is actually causing it. And the reason is, if I click on one of these, this is a little bit confusing, that one, but this is the reason. It's that when the UI clicks checkout and it fails, the web store tells us it fails, but was it the payment service? Was it the advertising service? Was it the product recommendation service? Was it the email API? Was it the authentication service? So this is the first step of, if you're going to move to Kubernetes and you have this idea of services, when requests fail, you need to be able to track those requests and see where they fail. There are many solutions for this. Again, I keep on trying to say that not Datadog disclaimer. There's a lot of ways to do this, but it's something that you need if you are going to be on Kubernetes. And then, being able to say, okay, like for instance, if I see this was a web store error here, being able to go and say, okay, show me underneath the container that was running here at the time. So this container might not even exist anymore, but I still want to be able to say, hey, was it because I ran out of CPU? Was it because I ran out of memory? Was it because it couldn't be scheduled at the time? Was it in crash loop backoff or something? So being able to go and attach, oftentimes I see when there's issues with like you get a 500 error in the web store, customers will go and check infrastructure information first. When it's really hard to know whether even if you find an infrastructure error, you don't know that that's what's causing it. If you start with this distributed tracing, then you can work backwards and check, is it the infrastructure? Is it the database? What do the logs tell me? Did someone do like a key error? Anything like that. But this is kind of step one if you're on Kubernetes, is you need to be able to track the distributed microservices. Okay, next one is increased release velocity. This is really just about deployment tracking. That's all this is that you should be able to see when you are releasing different versions of your app, at the very least, you should be able to say, what are the error rates, what's the latency? And this is at a service as a whole level, but also the resources within that service. So like, I mean, this is obviously a demo system. If I've got a 97% error rate, this was first seen 19 minutes ago, whereas this version is a like 0.37. Well, I mean, it seems like they've deployed it now, it's active. But you get the idea, it becomes fairly easy to say, oh, error rate shot up, let's move back to this version, done. And then maybe you can even go and say, oh, show me what pipeline ran that, I mean, this is a failed pipeline, so that's not going to be really relevant. But, okay, like this one run, this is our Shoppers. What is the last pipeline execution here? And what is the commit and the diff that actually caused it? So I can go and investigate what we think the change was that drove this kind of failure. So being able to bring CI/CD into the observability place. Again, I'm not even sure. Datadog connects these directly, so you can say, bring me back to the execution. Maybe you don't need that. It's definitely faster, but at least having the two sources of data there so that you can map one to the other and say, oh, we have a new version, we saw this, let me switch over into GitHub or GitLab and see what exactly that is that ran. So velocity is really about, I mean, there's a ton of, all of this relates to velocity. But in terms of being able to make data-driven decisions, you need to have version tracking in place. And thankfully, that's dealt with in Kubernetes with annotations. It's very easy. Okay, last one then is alerting. And this is about smart alerting. We already talked about SLOs. Your SLOs should not be 99.9999%, unless you are never touching the thing again. I actually was laughing a little bit. Is our JP Morgan Kubernetes book writer? Yeah. There it is, yeah. I was laughing a little bit because my dad worked at JP Morgan, and there are parts of the software that they're building cutting edge, new solutions, other things. There's other parts of the software that they're like, nobody touched that. It's been running for 40 years, and if you breathe on it wrong, it's a disaster. So maybe then it counts for 0.99999. If you're still developing, you need to think about SLOs, and they need to be set to user journeys. And then that's where you can say in the morning, you know what, I don't even really care about the 150 alerts I've got. I'm just going to look at the 5 SLOs that capture the major things we should be able to do, and are we hitting them? And that allows you to, first of all, relax, reduces war rooms, reduces incidents, and also then allows you to really only focus on things when they're really impacting the business. And the last one then is, once we get to a certain level of maturity, there will be a point, and I've seen this with all my customers, where you're putting your initial alerting in place, and it starts to catch the major issues you have, and then you put in automations, and you kind of reach this level of stability as things move. And then beyond that stability, we need to have some kind of anomaly detection, where we can just say, I'll get rid of, like, if I go to just logs. We don't want to constantly have to create our own logs. We just need a system that says, hey, we've never seen error logs from here before, or we haven't seen it for the past few weeks, and all of a sudden there's a bunch of them. Someone should investigate this. Or we can say, for infrastructure, percentage of unready pods is up. Number of pods in crash loop backup is up. And obviously all of these are kind of kind of resolved now, so it's hard to see. But this is kind of the idea, is there should be a system that just says, hey look, for this cluster, for this deployment, for this namespace, we're used to seeing 0 and now we see 4. That's when it starts to be more of a, just tell me if something is happening that is unexpected. That's kind of the next level. I have certain customers where they only use Watchdog as their, or they use anomaly detection as their basic homepage, because they've reached a level of stability in DevOps where they have a lot of these other ones in place. They know the system's probably fine. They have the static analyses and the front-end monitoring that they need. What they just need is, hey, did anything else weird happen? And hopefully, we're able to attach that then to, again, version deployments. Where if we're able to say, hey, something weird is happening that hasn't happened before. Latency is up, errors are up, something like that. And just before this happened, a new version got pushed. That makes at least, maybe not figuring out why it caused the change, but at least figuring out how to fix it and roll it back very quickly, that takes it down from hours to potentially minutes when we're solving in a kind of a Kubernetes environment. So last